you can ask. Okay. And coming to different levels of abstraction, what are the different levels, like in how many models we can write a Verilog programming? What are the different levels? Okay, before going to that, we'll discuss. Can you tell me how can we model a combinational logic circuit? Suppose a problem statement has given. Okay, how can you draw the circuit by using the problem statement? Multiplexer. Okay, so how can we draw a hierarchical multiplexer like 16 by 1 using 4 by 1 like that? How can we draw? What are the steps we
Need to
need to
use,
follow to design
need
any
to
type
use
of combination? Okay.
for 4
Tell.
plus 1 maximum. After that,
Okay, can you tell me in stepwise? Suppose a problem statement has given, we need to design a 15 by 1 multiplexer using a 2 by 1 multiplexer. Okay, first by looking into problem statement, what you will analyze first?
we need to analyze about the number of matches.
Okay, first you need to analyze the problem statement, whatever it has given. What are the different type of inputs? What are the different type of outputs? And is there any control signals or is there any data signals? Like if you take a multiplexer, it has a selection lines, right? First you need to analyze the inputs and outputs signals. Okay, after getting all inputs and output signals, you need to draw a block diagram. Just overall a block diagram you need to take. Okay, that is the first step. Second step, after getting a block diagram, you need to draw a truth table. Okay, truth table in the sense you have to take inputs, you have to take outputs. If there is any other signals, control signals like that, you need to take those signals and output. Okay, based on your input number of combinations, you need to take the output. That is nothing but truth table, right? After drawing the truth table, after writing the truth table, you need to take the output accordingly. Like you need to take the output expression. Okay, so how can you get output expression? Based on the SOP or POS. Okay, you already learn sum of product term equation and the product of sum equations and all. In terms of that, you can write, you can choose any model and you can write the output expression. Okay, so third step is output expression. Next, what is fourth step? By using this output expression, you will draw the circuit diagram based on the gates, or if you consider the flip-flop. Okay, accordingly, using the expression, you will draw the circuit diagram. Okay, from the circuit diagram, you can convert the basic gates into the NAND gates or NAND gates to CMOS gates. Okay, like that, based on that your conversion, it will happen. Okay, this is how any problem statement will be taken, right? Did you got the point? Okay, so based on these steps, we will write the Verilog program on every point. Like in every step, we can write the Verilog program. Okay, suppose by using the truth table, we can write the Verilog program. Okay, that is nothing but behavioral modeling we can call. And by using the expression, we can write the Verilog program. That is nothing but data
This
flow
data flow.
modeling. Okay, by using the circuit diagram, we can write the Verilog program. That is
Gate
nothing
level.
but gate level modeling, right? And also by using CMOS transistor, the circuit will be converted into CMOS transistor level, right? That is nothing but switch level modeling. Okay, so this is how we can write the Verilog program in various levels. Okay, did you got the point, everyone? Hello.
Yes, ma'am. Got it.
Okay, so behavioral is nothing but a behavioral representation describes how a particular design should respond to the given input. Nothing but the truth table. Okay, by using the truth table, you will write the program. By using the always block, by using the if else blocks, okay, by using loops, you can write that behavioral program. Okay. And for data flow modeling, it just describe the data between registers and how the data design will be processed. Okay, like just an expression, whatever the output expression is there, you will implement that expression in the block module. Okay. Next, gate level is the gates. By using the interconnection between gates, will write the program. And switch level modeling. And coming to 4 levels of abstraction, how a circuit can be designed in a 4 levels. Okay, we'll see here. For multiplexer, 4x1 multiplexer. Okay, so for 4x1 multiplexer, what are the inputs? I0, I1, I2, I3. 4 inputs and 2 selection lines, 1 output. Okay, so here module, name of the module, and inputs outputs. Can you tell me why we have taken here only simply as a I, S, O? Why can't we take I0, I1, I2, I3?
Because they are vectors, so we are just defining with a single input.
Okay. Okay, the vectors. Okay, if you take like this, we can reduce the number of variables. Okay, so easy to take, easy to extract. Like we can reduce the number of variables. If you take 4 variables, what happens means design complexity will be increased. Like number of variables will be increased. Okay, if you take like a vector format, 0 down to 3 or 3 down to 0, like that, within the same memory we can store the data. Okay, so this is a vector. If you take a single variable like a reg o, that is nothing but scalar. That is difference between vector and scalar. Okay, so I have taken 4-bit and S 2-bit register. Output is 0. Sorry, O, that means 0-bit. And always at the rate of star. Star means here we are including all the inputs in that. Okay, in place of star we can put these 3 variables. Not 3 variables, only inputs. Why we are taking only inputs in the sensitivity list? This is called sensitivity list. Okay, why we are taking only the inputs means based on the inputs only the output is going to change within the always block. Okay, if you are using the case statement or you can use if else block, okay, whatever the block you are taking, based on the inputs the output will be changed, right? So whatever the input change, automatically it have to reflect, right, to the internal functionality. That's why we are adding the inputs to the sensitivity list. Okay, suppose here input is changing I 0 0, then only only 0th bit of S is changing. Okay, but even single bit changes, that is a change of input. That should be reflect to the functionality, right? So that's why we are including every input in the sensitivity list. Even enable signal also you need to include, because based on that the functionality will be changed. Okay, so that is what always at the rate of here star. Star means by default it will include all the inputs. Okay, because here 2 inputs we can put easily, but if you take a project level or if you take a protocol level, okay, there will be many number of inputs out there, control signals or data signals or enable signals, whatever. So at that time we can maybe we miss some inputs. Okay, that's why if we put simply star, by default it will take all the things. Okay, and begin end. Begin end is nothing but we will write this begin end within the always block or initial block. There will be initial. Okay, here always and initial or procedural assignments will call. Those things we'll discuss later clearly. Okay, and case you already know, based on the we already used in C language and all, right? So if 2-bit binary 0 0, what is this 2B00 means? There are 2 number of bits which is declared in binary. If you want to declare 4, if you want to take 4 bits, then 4-bit binary like this. If you want to take in hexadecimal, 16H 24 56. Okay, each digit will represent in 4 bits. Okay, like octal, 8-bit octal. Suppose 764 like that. Okay, we will declare the values like this in Verilog. Okay, and at for 2-bit binary 00, O is getting I of 0. Whatever the data is there in I of 0, that will get into the O. For 01, I of 1, 10, I of 2, 11, I of 3. Okay, this is what the behavioral modeling of 4x1 multiplexer. Okay, clear?
Yes, ma'am.
You may get the doubt why we are using the output, why we are declaring output as a reg data type since it is a combinational logic circuit. Can you tell me what is the answer? Why we are using reg data type? Of course, it's a combinational logic circuit. Can you tell me, Jagdish?
We are going to store some time, ma'am. That's why we are using the JD.
We are going to store some time. Why we will
Which means
store
it hold the value, right?
Yeah.
Wire means it will continually assigns the value. Some other element.
Okay. But why here no need to store the value in the output, right? Then why we are using reg data type?
No idea.
No idea. Okay, why? Because see, here we are using the always block. Always is nothing but a procedural assignment. Okay, whereas initial and always blocks are procedural assignments. Whenever we are using the procedural assignments, the output should be declared using reg data type. Okay, there are two types of assignments, like a continuous assignment and procedural assignments. Those things we'll discuss later. Okay, tomorrow, not tomorrow. Okay, tomorrow we'll discuss. After completing these basic topics, we'll move to the lab session. Okay, then you will get to understand why we are using the reg data type and why we are using wire data type. Okay, so here why we are using reg means always is a procedural assignment. Whenever we are using always block, the output must be declared with a reg data type. Okay, remember this point. That is why we are using. Clear? Any doubts?
No, ma'am.
Jashwant?
No doubts.
No doubts. Okay. And coming to the data flow modeling, whatever you are writing the did you got the clarity? Any doubts?
No.
Okay. Okay. Next, coming to the reg data type, register data types. In register data types, we have synthesizable and non-synthesizable. Okay. Coming to the synthesizable, reg data type is the synthesizable. Okay. Here A is storing 4-bit value and B is storing 7-bit value. Okay. 3 down to 0 means just location wise it is in different. Okay. 0, 1, 2, 3. If you write the 0 up to 3 means the locations will be 0, 1, 2, 3 like that. The location will be changed, order of location. And here's 8-bit value, it will be stored. If there is only single bit means no need to put the vector format, that is scalar format. Okay, that is a reg data type which stores the data. Mainly we will use for sequential logic circuit. Whenever you want to declare the output, we will use the reg. Okay, and I told you, whenever we are using the procedural assignments like always, initial, that case we need to put, we need to declare output as a rich data type. Okay. Next, non-synthesizable data types or integer. Integer writes 32-bit data. Time is nothing but you will write $time in test cases to mention the delays, right? For that case we will use the time data type. Next, real is nothing but in C language you will use float value. Float value is nothing but decimal values. Okay, so that thing we will call here as a real. Okay, these are the non-synthesizable data types in the Verilog. We'll see one example. Integer A, real B, time C. For integer, we are assigning some 32-bit value. I already told you here in Verilog, we will define like this. If you want to define a 2-bit binary, like 2-bit tick B 00. If you want to take 4 binary variables, then 4-bit binary 0110. Like the decimal, in place of B you need to put decimal. If you take like that, here hexadecimal 32-bit we have taken, so 32 tick H and some value we assign, and B equal to some decimal value assigned, and #20, whatever the #20, whatever the delay is there, the delay will be assigned to the $time. That is nothing but C, and we displayed all the variables here. Okay, if you see here, there is some change we need to make. What change required here? Can you tell me? What change required here in display statements? Can you tell me? Hello.
No idea.
No idea. Just observe.
Yeah.
Other guy? Okay. Okay. Just see here. I will show you. Wait. Okay. If you observe here, A equal to 32-bit data. Okay. We have taken in a decimal. Decimal value is getting accordingly. Here float value. Again we took in decimal. The format specifier %LD. That means a decimal. Okay, and $time is okay, decimal it will be print. Okay, so 20, we got correct output for 20 only, remaining 2 we didn't got. Okay, exact value. So for that purpose, what we need to do, for hexadecimal we need to put H. Okay, format specifier. For the floating value we need to put G, %G. Okay, those things you need to modify here. H and G. Now run. Okay, if you see whatever the values we have taken here, integer data type we got correct value, and for float data type like a real we got correct value, and for C 20. Okay, see here there is a more distance. Okay, you can minimize this distance. Whenever you got like this, you can minimize the distance by putting simply width here, size width. Just 0 I am taking. That means minimum width. You can take 1, 2 or 4, like whatever the value based on the distance you want. Okay, see, now we got all values in a order. Okay, so this is how these are the different data types we have, which are non-synthesizable. These things we cannot use for designing. We can use only for test bench. Okay. Clear? Any doubts? Yeah. What is the difference between triple equal to and a double equal to?
I think double equal to is which is exactly equal to the value.
Then what
I
about
don't know
triple
about
equal to?
I don't know about the triple equal to.
Okay. So the difference is double equal to means it will only check with either 0 or 1. But triple equal to means it will check with the unknown value and high impedance value. Unknown means X, high impedance means Z. It check with the both values. Okay. So here are the example, like I'm taking A equal to 45, B equal to 9. Okay. It will check whether both are equal or not. Both are not equal, right? So the output will be 0. Here also the output will be get whether 0 or 1 based on true or false. Okay. So here next condition, A equal to 101x, B equal to 1011. Okay. If here we took triple equal to. If you take a double equal to, it doesn't consider this x. Okay. But here we taken triple equal to. Triple equal to means it will consider the x. Okay. It will check with x to this bit. X means either 0 or 1. But here we had only 1. That is not equal. Right. So we'll get it output 0. Next, third one, 101x, 101x. Both are equal. Okay. So here the output is true. Both are equal. And fourth condition, 101z, 1z00. Both are not equal. Okay, not equal. So here we took A is not equal to B. Yes, true. Both are not equal because Z is in a 0th position here. Here Z is in second position. Okay. And A equal to 39, B equal to 39. A equal to B is correct. And here also A is not equal to B. It's wrong. Okay. We'll do this example. We'll do simulation. We'll check how the unknown and Z values are working. Okay, see. Here we took X. So X is not equal here. And here X and X same values we took. But in place of triple equal to, we'll put double equal to only. Okay. We'll see what will happen if we put double equal to for that case. Okay, see, we got output as a X because double equal to is not used to check for unknown values or high impedance values. That's why we got the output as a X. Okay, that is main difference between equality and not equality operator. Clear?
Yes, clear.
Okay. Next, a logical
So
operator.
I had a doubt
Yeah.
here. So whenever I try to use an HDL, like in the simulation part, I have got the results in like XXX. So yeah, in VHDL, but not in Verilog. So I think
Okay.
this is the case I have written wrong in VHDL.
Okay, you
Is it
got
correct?
value X. That mean if you use double equal to, you got X.
Yeah.
Okay, then it is correct only now. That means it is not checking with the high impedance or unknown values by using double equal to.
Yeah.
Here also same. Verilog also same, right?
Yes.
Okay. If you use the triple equal to, then only it will check with the unknown values. If you use double equal to, it doesn't check. It check with only for binary value for 0 and 1. we will combine the values according to your statement. Okay, suppose if you see here, I am taking some value like a comma b of 3 down to 0 comma c comma 4-bit binary 1000. Okay, so how it will work? We will assign some values to a, b, c. Okay, so here a is nothing but taking all the value. All the value means whatever the a size. If we declare with a 1-bit size, or if you declare with a 4-bit size, automatically all the values of a will be printed, comma b of 3 down to 0. Whatever the size you have taken for b of b. Suppose if you taken 15 down to 0, or if you taken 8 down to 0, or if you taken 3 down to 0, whatever the size of b you have taken, particularly 3 down to 0 bits will be assigned, comma c. C also same, whatever the value is there in c, that value will be assigned, comma 4-bit 1001. These things will be assigned. Okay, I will take one example like now tell the answer. What will be the output?
100 100
100 100. Okay.
00 again 0
Okay.
0 100
Okay.
01.
01. So is that correct? Others?
I think B will be B of 2 output will be 1, not 0.
B of 2 will be?
I think it's 1, it's not 0.
It's 1. Okay.
Yes,
100
Yes,
100 1. Yes.
1.
So here it should be 1.
1.
Right? And C of 3 down to 1 means 100, because this is the 0th bit. Here 0th bit 1, 2, 3. So 100. It is correct, and 2 bits we assign like this, right? So this is a concatenated multiplexer using a 2x1. Okay, here in module I have taken a gate level multiplexer. How can you take a gate level multiplexer? First, you will take a 2x1 multiplexer which has 2 inputs, 1 selection line and 1 output. Okay, based on the input number of selection lines, you will write the truth table, right? Based on the truth table, you will get the output expression, right? So what will be the output expression here? Can you tell? Suppose selection line is S here, A and B are the inputs. So what is the output expression? S bar into
S
A
bar into A.
A
plus
bar.
S into B.
S into B.
So this is the output of multiplexer. Okay, so how can you design using the gates here? Suppose for S there will be a NOT gate, and there will be A inputs given to the AND gate, and here S before the NOT gate there will be one AND gate given to, both are given to one OR gate. This is nothing but output, right? So by using this gate level modeling, you can write this program. Otherwise, there is a very simple model by using the array model, which can be write in a single line. You can use any model. Okay. So here NOT gate. So output of NOT gate is S bar and input of NOT gate is S. So same thing we have written for NOT gate. And second AND gate, input is Like in one, here we have taken input as a S bar is another input, in one is the output. Okay, next for gate 2, B is the input, S is the input, in 2 is the output, and this into and this into in one, both are connected to one OR, which is declared as a wire because of interconnection between two gates. Okay, so like that we can write the multiplexer using gate level. And then by using this instantiation of multiplexer, and then by using this name of the multiplexer, we can take instantiations. So mux 2 1, name of the mux is M1, A of 3, A of 2, S of 0, in of 1. Okay, better just take, suppose this is 1 2 by 1 multiplexer, it has 2 inputs, and another 2 by 1 multiplexer, 2 inputs, 1 selection line. Both outputs will be connected to another multiplexer. Here output, here is another selection line. So here A of 3 is the input, A of 2, A of 1, A of 0. Like that, in 1 is the output, in 2 is the another output. Both are inputs to this 2 by 1 multiplexer. Same thing you need to write. A of 3 is the input, A of 2 is the input, S0 is the selection line, in 1 is the output. For second multiplexer, A of A of 1 is the input, A of 0 is the input, S0 is the input, in 2 is the output. For third also same. In 1, in 2 are the inputs, S1 is the selection line, out is the output. Okay. Have you understood? Clear?
Mm-hmm.
Okay.
Yes,
So,
ma'am.
so for this you can write a truth like a test bench. If you see here, A equal to 1010, selection line 00011011. Okay, we'll do the simulation. This is just a 4 by 1 mux using 2 by 1. Like that, write for 16 by 1 mux. Okay, using a small multiplexers, whatever you want. Okay, see the output here. If selection line is 00, whatever the data is there in here, the data get assigned. Because we are taking a 3 first. If you take A of 0 first, then this 0 bit will get assigned. But we are taking A of 3 first. Okay, so that's why the third bit is assigning to here. If selection line is 0 1, this second bit. If selection line is 1 0, this bit. If selection line is 0 0, this. Okay, so this is how we can write hierarchical multiplexers. Clear? Have any doubts? Complemented. For every 20 time unit, selection 2 will be complemented. Okay, just in a 3 steps you can get all the combinations of here 8 combinations. Okay, so at 5 time units, 5 time units, 5. Okay, at every 5 time unit, selection line is complement. So 0 1 0 1 0 selection line. For 10 time units, 1 will be complement. Initial, it is 0, next ones, zeros, next ones. For every 20 time units, it will be complemented. For all, it is 20 time units, next all ones, next again 20 time units, it complement. Like that, if you want to generate for like that, if you want to generate for 16 bit, for every 40 time units, it should be complement, like all zeros up to 8 and again all ones. Okay, so this is how you can take using always block simply. Okay, See here, what is the input? Input is 1. So initially you have to initialize with this value. If you don't initialize with this value with the 0 0, how can we take the values, right? That's why you have to initialize all selection lines with a 0 first of all. Then it will do the complement accordingly. Okay, so initially it is 0. So if selection line is 0, whatever the input is there, that input is get assigned at the first line. If selection line is 1, whatever the input is there 1, it should get assigned to the second line. Like that you will get the answer. Okay, this is about the demultiplexer. Okay, have any doubts? Like that hierarchical demultiplexer, whatever we did for hierarchical multiplexer, same as you need to do for hierarchical demultiplexer also. Okay, clear? Okay. Okay, let me recapture the things whatever we have discussed in the previous session. Can you tell me what is the difference between initial and always block?
And both are procedural blocks, ma'am.
Okay.
This always is sizable and initially not sizable.
Okay.
Ma'am, initial block and procedural always blocks both are procedural assignments. Initial block executes only at the beginning of simulation, and always block is continuous loop, and unless we terminate, it won't stop. And initial block is non-synthesizable, and we can only use this in test benches, not in design.
Okay.
Always block is synthesizable, and it is used in designs and test benches also.
Okay. Good.
Ma'am,
So,
initially is only used in test bench.
mm,
Always it can use it in both design and the test bench.
okay, good. So initial block will start at a 0 simulation time. Okay, whatever the delay is there, accordingly the delay statements will be executed. But all the initial statements will be started at a 0 simulation time. Okay, and what is the difference between begin end and fork join?
What, ma'am?
What is the difference between begin end and fork join?
And mainly begin and we will write whenever we have more than one statement.
Okay. Okay.
No idea.
Okay. We'll discuss those things today. What is mean by begin end and what are the blocking assignments, non-blocking assignments, and what is the difference between fork join, and those we'll discuss today. Okay, before that we'll see how many ways we can write the clock. How can we generate the clock? Okay, in Hello guys, in this session we'll discuss about tick timescale concept. Here the timescale defines it specifies the time unit and time precision of a module. The simulation time and delay values are measured using the time unit. Here the 10 nanoseconds left hand side is a time unit and right hand side is a time precision. We can take in the nanoseconds, picoseconds, microseconds, like that in terms of seconds. Okay, so here time unit I have taken as a 10 and time precision as a 1, 10 by 1, it's a 10. Okay, most of the students will feel the confusion here, but here we'll discuss very clearly without any confusion. See here, I have taken some data equal to 0, initialized with 0. At after some 1.56 time unit delay, some display statement is given, and hash 1.32 another display statement has given how much time we are noting down the delay of the time. Next, for at hash 0.50, what is the delay? And next hash 0.51, what is the delay? So here the time unit is a 10 nanosecond by 1 is nothing but 10, right? So this 10 will be added to the value here, the delay value. So 1.56 into 10 is nothing but it around the 15, right? 15.6. So 15.6 will be rounded off to the integer value. 15.6 means it is rounded off to the 16, right? Like that, the next statement delay 10 nanoseconds into 1.32 is nothing but it's around 13.2. So this 13.2 is rounded into the 13. If if it is greater than 13.5, we can round it off into 14. But it is less than 0.5, so we can round it into 13. Okay, next one 0.50. So 10 into 0.50, whatever the value we got, that value will be rounded off. Okay, and hash 0.51 into 10, that value will be rounded off, and hash 5. Okay, this is how we can get the output delay value. Suppose here 16 plus 13, 29. Next 29 plus here what 5. Okay, like that we'll get the output. See here the output how at time 16 this statement, first statement is displaying 1.56. At time 29 1.32 statement is displaying. At time 34 like 29 plus 5, because here this 0.5 into 5 10 is nothing but 5, it is rounded off to 5. Next again 0.51 is rounded off to 5, so 39, and again 5, 10 to 5. Okay, 50 plus previous value. Okay, this is how we can take the precision. Okay, and then I'm considering 10 nanoseconds by 1 nanosecond by 1 nanosecond is nothing but 1. So there will be no difference, much difference. See here for 1 nanosecond, what is the value, here 1.56, right? 1.56 into 1 is nothing but we can round off to the 2, right? Next 1.3 into 1, 1.3 means we can round it to 1. So what 2 plus 1 at 3 at 3 time unit, this statement will be executed. Okay, next 0.5 into 1, it's around 1, right? So 3 plus 1 at 4th time unit we can display this statement. Okay, like that again 0.51, like we can round it off to 1. So 1 plus 1 at 5 time unit. Next one is a 5, right? 5 into 1 5, so plus 5 at 10 time units, last display statement will be executed. Okay, this display statement will be executed at 10 time units. Like that, if we consider 1 nanoseconds by 1 picosecond, 1 nano by 1 pico means it's around 1000, right? So same 1000 will be multiplied with the delays. Okay, if you see here 1000 into 1.56 means it's around 1560, right? So 1560 will be at 1560 this statement will be executed. Okay, and then 1.32 is nothing but 1320, it's around. So 1560 plus 1320, whatever the value 2880, at that time the second statement will be executed. Okay, here no need to round off because already there are the integer values, right? So no need to round off. Next 0.50 into 1000, whatever the value we get, we will added that value to the previous value. Okay, if you have any doubts, please comment below. Okay, thank you.
Now we'll see how to generate the clock using always block. Generation of clock using always. You're commenting this line, and first we have to create one module with some name, generation of clock, and we have to declare the clock, and I'm taking number of clock cycles. Now I'm initializing the clock value with a 0. Clock is equal to 0 and number of clocks is equal to 0. And when we are using multiple statements within the begin and then we have within the procedural blocks, then we have to include begin and. Next, always block. Here I am taking clock period as 10 period, 10 time units. So each clock must have 10 time units. That means half clock will have 5 time units. I am taking the delay of 5 time units. So #5 clock is equal to not clock, and I am taking always and posage of clock just to count number of clock cycles. Number of clock cycles. Here it will count number of clock cycles. And another initial block I am considering to display the values. I am considering the monitor here to display every change of the value. And at 100 time delay, I want to display number of clock cycles. So number of clock cycles, it is just mandatory. $finish to terminate the execution at 100 time units and end module. Now we'll see how the simulation result. See here, using always block, we are generating the clock here. Initially, the clock is 0 and every clock has 10 units delay. The time period is 10 units because here we are considering as 5. That's why the clock time period is 10 time units. The clock is generating up to 100 time units, below up to 100. That means 95. And the number of clock cycles are 10. Number of clock cycles are 10. If you want to see in a waveform, in the form of waveform, then we can use some $dump file. Just we have to dump the file here. Dump.vcd. Dump vars. I'm taking 0 here. We can take 1. There is a difference. And we have to select the option. Then we'll see the simulation waveform here. The number of clock cycles are 10, 0 to A, and the time period of every clock cycle is 10 time period, 10 time units. And this is how we can generate the clock using always block. Next, second one, generation of clock using repeat. Generation of clock using repeat. Here I'm not taking any number of clocks to check number of clocks. I'm not taking, just I'm taking how to generate the clock. So initial, begin, I'm initializing clock is equal to 0. We can initialize with 1, your wish, and repeat of 10 times. I want to repeat the clock 10 times with a delay 5 time units. I want to display the clock. And $time to display the time, simulation time. I'm considering the system task $time, and here there is no need to take any finish, because automatically it will terminate the loop whenever the repeater, whatever the value you are considering in repeat, after reaching that value it automatically terminate the execution. So if you want to check the waveform, if you want to see any waveform, then we have to write $dump file and dump variables. And now we'll check. So here we can observe the waveform using repeat block. Here we are repeating 10 number of times. Each clock period is 10 time units. Here clock period is 5 time units, and here half duration t by 2. If we consider the total clock period as t, here t is equal to 10. T by 2 is equal to 5. Like that we can consider the clock period. And here we are generating up to 10 clock pulses. Here we can see clearly, by using the repeat we are generating 10 times. Clock is equal to not clock is equal to 10 times. That means 5 full cycles. We'll get 5 full cycles here. At 50 time, after repeating 10 time clock cycles, it will automatically terminates. No need to use any $finish or $stop to terminate the execution. This is how we can generate the clock using repeat. Like that we can generate the clock using forever. In place of repeat, we can directly take the forever. Forever, if it will repeat the clock, not only clock, whatever inputs we are considering, the loop will not terminate until until we terminate the execution by using the $finish or $stop. So externally we have to use $finish. At 50 time delay, I'm terminating the execution here. See here, at 50 time units, the execution automatically terminates. 10, 20, 30, 40, 50. At 50 time units, the execution automatically terminates. Here we can see the clock, how it is generating. Initially it is 0. Again the not clock, that means complement of clock. If we want to finish at 100 time units, we can take the delay more. Then it will the execution will be terminated at 100 time units. See, observe here. Here the execution is terminating at 100 time units. This is how we can generate the clock in Verilog HDL. These are the different styles of generation of clock in Verilog HDL. Thank you.
What is the difference between task and functions in Verilog? Tasks are non-synthesizable. Okay. So, function cannot contain the simulation delay. Okay, whereas task has the time delay. We can specify the time delay for task like hash or await or any negate statements, pause statements, which are time control statements, we can put in task. But whereas function won't accept those things. Okay, so a function can return a single value, whereas task returns multiple values as output or in-out arguments. Okay, it can return a value that which function can do. And function cannot call other task, but whereas task can call other task and also functions. Okay, those are the main differences for function and task. Okay, have any doubts? We'll see example how the task and functions are defined. So this is the function. Another thing, function and task both are synthesizable. Okay, functions, there is no such thing function should be used only in synthesizable, not in simulation, not like that. Functions and task both are synthesizable, but here tasks are using time, right? So whenever we are using a simulation time and all in synthesis, it will not accept, it will not consider, okay, in the synthesis. So here we are taking the function example. Function name is compare and we are passing these arguments like a input. Okay, function return value, so no need to mention the output in the arguments. Okay, if a is greater than b, it is displaying some statement. If else, if a is less than b, some statement, else a displaying some statement. Okay, so this function compare we are calling from another block. Okay, so initial begin compare passing some values 10 comma 10. 10 is the a input, another 10 is b input. Second statement 5 comma 9. A is 5, b is 9. Like that we are passing these arguments to the function. So it will call, we are calling the function here and the statements are executing. So if you see a is equal to b, here condition is true and a is less than b, and this condition is true, and a is greater than b, this condition also true. So this is how we can execute the function. If you write the delays here, it doesn't accept the delay. Okay, we will try with the delay also, how the function will get error, it will get the error. Okay, and we'll see another example for task. Task example, task compare. Here we are giving arguments like input a comma b and also output. Both types we can take in the task. So if some statement happens, it is printing the display statement, else if another display statement else. Here we are putting some hash 10. Okay, and next initial block we are calling the task from the next initial block. Okay, initial begin some bit done. Here we are telling like a bit done, that means just to observe the delay here. Okay, if you don't want to observe any delay here, no need to put done. Okay, and compare 10 comma 10 comma done. 10 is input A passing that value, and another 10 B output done passing done. And next one, so if done is high, it is comparing with the time. That mean I told you in the task we can use the simulation time, right? So $10 we are checking with the simulation time here. So once done equal to high, it will display this time related delay. And compare task again, 5 passing to the A and 9 passing to B, output done. So again displaying the statement. Like that compare statement, again displaying another statement. We'll do the simulation. So see here, A is equal to B. As we passed 10 equal to 10, and the statement is A is uh, greater than equal to B, this else statement is executing. And once done equal to 1, we are comparing the completed time. So initially 10, again for next statement it is 10 plus 10 20, and again next statement 20 plus 10 30. Like that we are comparing the time as we are using the delays in the task. But suppose I am putting here function in place of task. I am putting function end function. So what will get error, because one thing, we cannot pass the argument here, output we cannot pass in the function. Uh, that is one error will get, and also time. See, function compare should a return value, it will just return a value. Okay, whatever the input arguments we are sending, it just return the value, it doesn't uh, take the in out value, in out or output value we cannot mention. And also function compare result is ignored. Once that statement is ignored, all these statements will be ignored, right? So compare, so we cannot pass this argument done if we use the function. Okay, so this is the difference between task and function. First question, did you understood? Everyone have any doubts? Okay, next, coming to the second question, which of the following statements are true? Can you tell me which of the following statements are true regarding function? Let me compare.
B and C.
B is true up. Okay, let me check. B, function should not include delay. Okay, correct. And functions are basically used to synthesize only combinational logic circuits, and the end result of this function can be used as data input to the flip-flops too. Yes, that's also true. Okay, functions we'll use mainly for synthesizing the combinational logic circuit. Whatever we have generated something, some output from the combinational logic circuit which is using by function, those things can be fed to the flip-flop also. So option 1 is also correct. And function may call other function but not task. Yes, true. So task can call other functions and also task, but whereas functions cannot call other task. Okay, and function doesn't return a value. Is it true?
No, ma'am.
Function returns a value, right? So any doubts?
No doubts.
Okay. And coming to third question, what is the difference between regular delay, inter delay, and intra assignment delay? We already discussed these delays whenever we are discussing blocking and non-blocking assignments, if you remember. Can you tell me what is the difference between regular delay, inter delay, and intra assignment delay? Regular delay execute the before simulation. Okay. Next, intra assignment delay after execution. Okay. Okay. So I have given three options here. Which one is a regular delay, intra assignment delay, and inter assignment delay in these three? Okay. First one is regular delay, regular assignment delay. Second one is inter assignment delay, sorry, intra assignment delay. Third one is inter assignment delay. Okay, as you said, Pavan Kumar, B is correct, intra assignment, but C is also regular assignment. This also regular assignment, and C can be considered as inter assignment also. Both are same, regular and inter assignment. Both are same. Okay, so regular assignment. If you use the blocking assignment or if you use the non-blocking assignment, the delays will be added to the next statement, right? So if you take the intra assignment, what happens for blocking assignment? The delay will be added to the next statement. If you take the non-blocking assignment, the delay will not add to the next statement, right? That's why for non-blocking assignments, we will write using the intra assignment, which is the delay is internal, that means RHS side. Whereas inter assignment delay, it is also like a regular delay. For blocking assignment, the non-blocking assignment, this 10 will be added to the next statement. Okay. Now, can you tell me what is the value of a C here? At what time the C statement will be executed? Can you tell me the execution process here? So A equal to 0, B equal to 0, 0 plus 0 is 0. So the value of A and B at a time 0, it will be evaluate, but it will wait for 10 time units. After 10 time units, it will assign to the C. Right. Whereas second C condition, what is C condition? It will take the value of A and B in the current time and it will store to the temporary variable and it will assign to the C at the 10 time units. At 10 time units, both are similar. Okay. Did you understood everyone? Have any doubts?
No, ma'am.
Okay. Next, what is the difference between parallel case and a full case? Okay, the difference between parallel case and full case is nothing but in full case, all the combinations will be written. See, here I have taken A as a 2-bit. 2-bit means how many combinations? 4 combinations. For all 4 combinations, we assign some value here. We took all 4 combinations. That is nothing but full case. Okay. Whereas parallel case means A again 2-bit here. 2-bit means 4 combinations, but we didn't mention 4 combinations here. By using the don't care, question mark is nothing but high impedance, case X or case Z you can put, right? So this is nothing but parallel case. That means 0 question mark means it will generate 0 0 0 1 parallelly. 1 question mark means 1 0 1 1 parallelly. Okay, so that is the difference between full case and parallel case. Okay, got it? Question: which is used to introduce delays in the circuit? Can you tell me what is the answer? which is used
Buffer.
to delay element, because the buffer is the delay element. Okay, not only buffer, every gate has a delay. Okay, inverter has a delay, XOR has a delay, flip-flop has a delay, different delays. Each gate, each component will have different delays. Okay, but buffer means it doesn't change the value. That means whatever we are giving the input, output is also same. Okay, so it doesn't change the value. That's why wherever you want to match the delay with the remaining signals, like with remaining parts, suppose here one AND gate is there, is connecting to another input, and here one XOR gate is connecting to another input, and here some AND gate, and also output of AND gate is giving to OR gate to another some gate. Okay, so here delay mismatch is there. Whenever delay mismatch is there, what happens in output will get glitches. Okay, there is a chances of glitches, because this input is getting sometime this input asynchronously, all inputs are getting to the gate. Okay, that's why to avoid that asynchronous, we are using the buffers here. How many buffers you need to say put same as this path, we will use those many buffers. Okay, by increasing the delay we can achieve that thing. Did you understood, everyone? That's why buffer is used to delays, to increase the delays. Input IN1 is equal to 4-bit 101x, and input 2 is 0 1 0 1. So what is the output? Input 1 plus input 2 means what is the output here? Which option is correct?
Don't care, ma'am.
Why don't care? Why don't care?
Doing any operation with don't cares, it returns output also don't care only.
Which type of addition operation it is? Which type of addition operation? 101x and 0101. Which type of addition operation it is? Bit by bit, bitwise operation, right? It is performing like that. X plus 1 is nothing but x. 1 plus 0 is 1. 0 plus 1 1. 1 plus 0 1. So 111 x. Here we don't have that option, right? So D is correct answer. None. Okay, suppose it is not you can't tell here directly x, because it is performing bitwise, bit by bit. Remaining bits are valid. Okay, did you got the answer? Did you got the idea? Everyone have any?
Yeah, ma'am.
Okay, next question. What could be the expression for the below figure? In 1 and in 2 or the input range variables, and output is wire type. Wait just a second, I will show you the waveform. Okay, so here is it visible? Here input 1 something waveform is given, and input 2 some waveform is given, and output also given. Okay, what is the question here they are asking? What could be the expression below figure in 1 and input 2 or range variables, and out is the output variable? So which option is correct according to the waveform? How the output, can you tell me what is the output expression here?
Ma'am, can you repeat, ma'am?
Okay, see, what could be the output expression from the waveform. That means two inputs are given, some waveform has given for two inputs and out also given. Okay, you need to get the output expression based on the two inputs. How you will get output expressions based on two inputs? You need to search for scenario 0 0 0 1 1 0 1 1. Okay, so for 0 0 input, what output is getting? For 0 1, what output is getting? 1 0 1 1, what output is getting? These four conditions you need to check in the waveform. Okay, so like that you can tell what is the output expression here, what exactly it is performing.
The operation, ma'am. Second second option is correct, ma'am.
Okay.
Like you said, delay is 10 nanoseconds.
10 nanoseconds. Okay, yes. So here, if you consider 0 into 0, output should get 0. 1 into 1, output should get 1. Again, here it is changing 0 into 1. That means output should get 0. 0 into 1, again output should get 0. 1 into 1, output should get 1. Okay, but exactly whenever input is triggering, output is not triggering. Okay, it is changing after some delay. That means here whenever it is triggered to 1 both the inputs after 10 time units, here delay is 10 time units. After 10 time units the output is triggering. So the answer is 10 time delay. Suppose A and B, input 1 and input 2, that is the correct operation, right? So option B is correct. Have any doubts?
No, ma'am.
Okay. Next one. Fourth question. What is the value of the given Verilog code? Suppose here always at the rate of clock A equal to 0, A equal to 1 has given. Okay, and of A. So here A is displaying. So what is the value of A here? What value it will be displayed?
Initially, A equals to 0 will be displayed, ma'am.
Why?
Because blocking element, ma'am, it is in active region.
Okay. After that, which statement will be executed?
Non-blocking statement.
Non-blocking assignment. Okay. 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 Whatever she told, it is correct. Because A is equal to 0 is the blocking assignment. First blocking assignment will be executed and then non-blocking statement will be executed. So first A equal to 0. After some simulation time, A will be 1. Okay. So A equal to 0 at current simulation time and A equal to 1 for the next simulation time. Next question. Analyze the code given and choose the right answer here. What is the code given here? Top module, assign A equal to A and or B. Initial begin force. Okay, force means it is trying to execute, forcing the value. This value is forcing to out, and release. Release means stop. Okay, it should not execute. So what will be the output here? Option
Fourth
B.
option, ma'am.
How? Deepa, how option B is correct? Okay, tell how option D is correct.
Ma'am, as mentioned above, x is equals to 7 and y equals to 5. First to instanting with a name RTL circuit, ma'am.
Okay.
And then giving the delays X and Y, ma'am, as mentioned in the parameters for the RTL circuit.
Okay, yes,
So
correct.
7,5 RT1.
Okay, correct. Okay, good. So maybe you think A is correct. So because X is 7, Y equal to 5, maybe A is correct. Somebody can think, but why A is not correct means whatever the port list has given here, the port list is not equal to it is not same to here. Okay, here it is a x comma y and here y comma x. But in the design, however you are taking the port list, in the test bench also you need to take same port list. If you don't taken, what happens? Mismatch will be get. Suppose here x is a different output, y is a different output, so you need to connect in the port list x to x, y to y. If you are taking some other variable, then also you need to connect with the those related variable only. Okay, if you don't take correct variable, your output will be mismatch. So this fourth option is correct. Okay, did you understood everyone? Whereas x is the delay 7 and y is delay 5.
Yes, ma'am.
Okay, next, ninth question. What is the difference between $display, $write, $monitor, $strobe, $finish, $stop, and $random?
Dollar display means it will display the keyword వాడితే మనం output display అవుతుంది.
Okay.
$displays $monitor is to display the output onto the screen.
What? Can you tell again?
To display the output onto the screen.
Monitor, display, or strobe, or write, everything use it to display statement on the console
Yes,
only.
yes.
But there is a similarity between 4. We need to understand the similarity. So that's what I'm asking.
In the monitor statement, when all the mentioned statements in the monitor, if there any value changes, will display.
Okay. Any
Whereas
other
in the
answers?
display,
Okay. Yeah, tell.
whereas in the display, whenever that statement occurs, it will display.
From display.
Only
From
once
dollar.
it will display.
Okay. Any other answers? Okay. Dollar display is nothing but it will display immediate value. Okay. Suppose immediate value in the sense, here I am taking one display statement, second display statement, third display statement. After third display statement, I am putting as a dollar display. Okay, so in this print statement, only this value will be printed. First two values will not print. Okay, for suppose I am taking dollar display here. After first statement, I am taking the dollar display. Okay, then this first statement will be executed. Middle statement will not execute because dollar display means it will execute immediate values. It will print immediate values. Okay, so before dollar statement, dollar display, it is the statement, and for this display statement, it is the before statement. Okay, that's why these first and third statements will be executed. Okay, whereas a dollar monitor means it will execute for every change of input. Suppose I am taking dollar monitor at first, so I am changing all the values variables. I am changing here a equal to b something, a equal to 0 at 5 simulation time, 0 simulation time, like that I am changing a value. Dollar monitor means it will take every change of the input. Whereas a dollar strobe means, okay, current simulation time. statement will be printed by using the $strobe. $write is nothing but same as a display. Okay, but whenever we are using $display, immediately it will go to the next line. Okay, but whenever we are using $write, it doesn't go next line. Suppose here 4 statements are there. I'm using the 4 display statements here: display 1, display 2, display 3, display 4. Okay, all these 4 statements will be printed in a 4 lines. But when I am using $write, all the statements will be printed like this by using the $write. It doesn't go for next line. If you want to go for next line, you have to use the /n to go next line, as you are using in C++, C language we'll use, right? So like that we need to use. Okay, so what about $finish and $stop? What is the difference between $finish and $stop?
$finish is to stop execution.
Okay.
Come into a $stop, it will come out of the simulation.
Okay. So $stop is nothing but the simulation will be suspended. Okay, suspended, and here the simulation will be terminated. Okay, that means termination means this task will be exit from that simulator and it pass control back to the operating system. That is nothing but termination. But whereas here it will be suspended. Okay, so that is the difference. And what is mean by $random?
Assign random value.
It generate the random value. Okay, $random means whatever no need to give the hard coded values for the input variables, directly it will randomize the value. So that is one of the benefit when we are using a complex variables, complex number of variables. Okay, so that is a $random. Did you got the clarity, everyone? These are system tasks. We also have different other system tasks like a $dump file, dump fats, dump off, dump on. So you can concentrate on those. Okay, have any doubts up to now?
$strobe once again, can you say?
Okay, that's what we are discussing here in question 10. We'll discuss that thing. Any doubts? Others?
No, ma'am.
Okay. See here, what will be the value of y printed in the console? Here, what is the code? Reg 3 down to 0. Why we have taken $strobe at some simulation time, $time. It is also a system task to print the delays, to print the time. Y is equal to something we are printing here. After that, we took 2 statements and hash 20, y equal to something, and again y equal to something. We took this $strobe. So what will be the output here? Which statements will be printed in the?
It will execute the delay time.
It will execute delay time. Okay. What will be the value of y?
I think it's 0.
Y 0. Why it is 0? It will print this statement.
Yes, ma'am.
Okay. This $strobe will print that statement. What about this $strobe? So at the 0 simulation time, what is the last statement? Y equal to A is the last statement. After 20 time units at that current simulation time, what is the last statement? Y equal to 0. Okay, so for this first $strobe value, it is at the 0 simulation time. So in that 0 simulation time, the last statement is y equal to A. And next for $strobe, 20 after 20 time units in that current simulation time, the last statement is y equal to 0. So here A will be printed, here 0 will be printed. Okay, suppose if I am using a same place a dollar display, here dollar display, what statements will be printed? Here I am taking dollar display, here also dollar display.
0 will be displayed.
Here 0 will be displayed. What about this dollar display statement?
A will be displayed.
Here unknown X will be displayed because there is no value before this dollar statement. There is no value assigned to Y. Okay, so here unknown will be displayed, one unknown will be assigned to Y, and immediate value means here 0 will be assigned. Okay, otherwise if you want to display these 4 values using the dollar display means what we have to do? Here we need to put one display statement, here one display, here one, here one. 4 display statements you can put. Then it will print every immediate value. That is the dollar display. Dollar monitor means I can put only here dollar monitor. It take every value change. Okay, so that is the dollar monitor. Did you got the clarity, everyone, now?
Yes, ma'am.
Okay. If you don't get the clarity, please let me know. Okay, next question. What is the result of the below code? Here a module has given with the addition and repeating 5 number of times. Add 1 equal to $random modulo 10. $random modulo 10 is nothing but here $random is randomizing the value. Okay, then what about this modulo 10? Okay, see, percentile 10 is nothing but it will assign the values 0 to 10. It will randomize the values 0 to 10. Okay, percentile 10 means here only maximum value we have assigned. Minimum value we didn't mention. So minimum value will be the 0 always. So 0 to 10. Between in this range, it will generate the random value. Okay, so in the first case, it is a signed. Signed means both positive and negative actually. But here 0 to 10 means we don't have positive and negative, right? So it is a signed, and unsigned means only positive values. Here in this case, it will generate 0 to 10 unsigned value. Okay, did you got the idea now?
Yes, ma'am, got it.
So this is how we can randomize the values in Verilog. Next question. What is the result of the below code? So here what assignment we have used for add? 40 plus $random modulo 50 minus 40. So what values will be generated? What values will be randomized to the add? Can you tell me?
0 to 10, ma'am.
Why 0 to 10? How? How 0 to 10?
50 minus 40 equals to 10, ma'am.
50
And
minus 40. Okay.
And 40 plus 10, ma'am.
Okay, but we cannot use like that. Okay, this is the expression. Okay, what is the expression means? Minimum value plus $random modulo maximum value minus minimum value. Okay, in this case, it will randomize the value between maximum value to minimum value. Sorry, minimum value to maximum value. So minimum value is a 40 here, maximum value is a 50 here. So between 40 to 50, it will randomize the values. Okay, did you got the point now?
Yes, ma'am.
You can try all these things using EDA playground. Okay, then you will understand how these values are generating exactly. You can put as a signed, unsigned, you can generate minimum to maximum. In Verilog, we can use only the $random. But in system Verilog, if you go, it is a advanced level. We can randomize there and we can control the randomization there. Okay, how can we control means, suppose here 40 to 50 random values are generating. Okay, we are telling repeat a 5 number of times. Repeat 5 number of times means it may generate 41, 42, 3 times 42 it may generate, and next 47. These random values it may generate. But what happening here, 3 times the same value is repeating. If 3 times the same value repeat means number of scenarios are reducing, right? In place of these 3 values, if we generate other 2 different values, we'll get more scenarios. We can observe in more scenarios. But here it is taking 3 values, 3 different scenarios for single value. That is the disadvantage in the Verilog. Okay, if you go in system Verilog, when we are doing the randomization there, by using rand we can do the randomization by putting input variable as a rand. But this case we can avoid. How? Because how means we can put simply as a rand c. Rand c is nothing but it is a cyclic manner. It will repeat the cyclic form. So once a value generate, until all the values generated again, then only it will generate the same value by using the rand c in the system Verilog. That's how we can avoid these things. Okay, and also in system Verilog we have the controllability. We can write the constraints. Okay, constraints in the sense we can control the randomization. Like if you want to generate between 100 to 200, between 100 to 200, or greater than 100, like that we can write the constraints. So like we can have more controllability on randomization. Okay, but Verilog we don't have such things. Did you understood everyone? Next question. What is the result of the below code? Here a counter code has given with a clock, reset, counter, input and output, always at the rate of POSH clock, if condition and else condition. So what type of counter it is? What is the size of the counter? 4-bit size.
4-bit.
4-bit size means it has a 4 number of flip-flops. Okay.
Flops.
What type of counter? +1. +1 means it is a incrementing. Incrementing
Yes.
means up counter. Okay. 4 number of flip-flop means it will count between 0 to 16. 0 to
16 bits.
15. 0 to 15.
Yes.
So will it count 0 to 15 here?
No.
Why? Why it won't count 0 to 15 here?
It is up to 9 only, ma'am.
It is up to 9 only. So it is a modulo 9 counter. 9 means 1, 0, 1. Okay. So this and this we need to connect to the NAND gate input. Okay. Because to make this flip-flop 0 and this flip-flop 0, it should go to reset state. Okay. So output of NAND gate will be connected to the input of clear signal. Okay, input of clear signal. Here active low clear signal we are using. So once whenever in output of NAND gate is 0, whenever we are feeding inputs as a 1 to the NAND gate, the clear signal will be activated and these two flip-flops will be reset, and all flip-flops will get 0 after reaching to 1, 0, 1. Okay, suppose if I want to use as a modulo 9 count, modulo 6 counter, what is the value of 6? 0, 1, 1, 0. Once it reaches 0, 1, 1, 0, then these two inputs, 1, 1, I am connecting to the input of NAND gate, then it will make a 0 output. Then this 0 will be connected to the clear signal. Then these two flip-flops will go to the reset state. Once these two flip-flops go to reset state, output will be all zeros. That means it will print from 0 to 6. Again it will go to 0 reset state. Okay, so here this circuit working as a modulo 9 counter. Okay, did you got the point, everyone?
Yes, ma'am.
Okay, next question. A timescale has given 10 nanoseconds by 1 nanosecond. Value is given, initialized value with a 0, and after one time unit, display statement has printing and value equal to 1. After 1.24 time units, display statement. Again after 1.50, 1.90 and #5. Now tell me at what simulation time which display statement will be printed. First of all, everyone know this time scale concept?
No, ma'am.
Okay.
No, ma'am.
Okay, see here. 10 nanoseconds by 1 nanoseconds. Time unit, time precision. Okay. So time unit will be divided with the time precision. Time unit must be high every time. Okay. So time unit is high here. So 10 nanoseconds by 1 nanosecond. N same. So N we can cancel. 10 by 1 is nothing but 10. Okay. So this 10 will be multiplied for every simulation time. Okay, every simulation time that 10 will be multiplied. Now tell me the answer. First statement, at what time it will be displayed?
10 nanoseconds.
10 nanoseconds. Okay. Next, this one.
10.24.
10 into 1.24. So 10.24. Okay.
Next will be 10.50.
Add the delay. 10 into 1.24 is it 12.24, right?
Yes, ma'am.
10 it is a 12.24. So you need to add these two delays. Then what will be the output? 10 plus 12, it is a 22.4, right? And what is this delay? 1.50 into 10.
15.0 plus 22.4, ma'am.
Okay, 15.0 plus 22.4. Whatever the value is getting, that is the value here. Okay, next statement.
19.0
19.0 plus 37.4.
37.4.
Whatever the getting the value here, that value will be added to next. Okay, 5 into 10, 50 plus this value. Okay, so at those simulation time, the display statements will be printed. Okay, did you got the point, everyone?
Yes, ma'am.
Okay, so this is how time scale. 10 nanoseconds by 10 nanoseconds. If I give what you need to do, 10 by 10 is a 1. So with every statement here, every delay you need to add with a 1. Okay, if I give 1 nanoseconds by 1000 picoseconds, okay, then what you need to give, 1000 will be the value and you need to put multiply with the 1000. Okay, like that you can increase the delays and you can check the value. Okay, and next question, what would be the simulation time in the below code? Or value equal to 10. Timescale is given as 1 nanoseconds by 1 picosecond. Okay, can you tell me what is the value of 1 nanosecond by 1 picosecond? 1000. It is it? 1000. So R value equal to 20. R value again we are taking R equal to 10. Okay, at what time? After 10.56. This 10.56 must be multiplied with 1000. What will be the value? Around?
How it is 1000?
How it is 1000? What is the value of 1 nanosecond? 10 power minus 9 divided by 10 power minus 12. Okay, after cancellation, it will remain 10 power 3 is nothing but 1000.
So above means numerator part will be always highest value. Like
Yes.
suppose it is 1 ns by 1000 picosecond. That time what it
No.
will?
Here time unit, this is the time precision. Time unit must be greater than always time precision. Okay, time unit must be greater than precision. So this is the condition we need to check every time.
So if it is not greater than?
If it is not greater than, we will get negative values. Do we have negative time?
No.
Then that's why it should be greater than always.
So
Okay,
if
you
we
can
have
try.
like one ns by suppose we have 10 ps.
10 ps, then what will be after all doing? We'll get 100. Yeah.
Yes.
So 100 we need to divide with all this. Sorry,
Okay.
multiply with this value.
Got
Okay.
it. Got it.
Okay.
Yes.
Like that, you cannot take 10 picoseconds by 1 nanosecond, because 10 picosecond is very minimum value, 1 nanosecond is greater value. So you will get the negative value here. Again you will get 10 power 1 power 10 power 3, like that. So which is a negative value here. So we cannot consider that value. Okay.
Okay.
Yeah. Have any doubts, others? Have any doubts? So what is the value here?
10566 and 10,566, ma'am.
Okay. Option C is correct. Okay. And next question. What is the order of execution for the below code? Reg ABC, A equal to B equal to C at 0 simulation time. So the statement has printed here, and A non-zero simulation time C equal to 0 and A equal to 0, B equal to 0. The statement has given. So what is the order of simulation here? You can check the options here. Thinking 0 delay statements will be executed first, or otherwise the non-zero statements will be executed first, then 0. Can you try this simulation? Then we can understand which statements will be printed. Hello.
Yes, ma'am.
I will share this code in the group. Just try and let me know which statements are executing first. Okay. Then we can confirm any of the option. Okay. Have any doubts? Okay. Next question. Analyze the code and find the output. Here we are using the fork join. What is mean by fork join? Can anyone? What is mean by fork join?
Parallel threads.
Yes, these are the parallel execution statements. Okay, whereas begin end is the statements will execute serially when we use begin end. But when we use fork join, all the statements will execute parallelly according to the delay, right? So can you tell me what is the output, at what time what statement will be executed? What will be the output? First #10 has given, and then within the begin within the begin and first statement #10, and within the fork join 20 10 5. So which statement will be executed first? As
First
begin and
delay, ma'am.
yeah, tell.
First delay 5
First delay 5. Okay.
will after that 10 and next 20.
Okay. Within the fork join, those statements will work, will execute accordingly. Okay. But fork join is there within the begin end. Within the begin end. First begin end will be executed, right? In begin end, all the statements will execute serially. So which statement will execute first?
First will be executed #10.
#10.
First
Okay.
statement before fork time.
Okay.
Then it will be executed your 15 and 15 #15, the third display.
#5 plus #10.
15.
Okay. At 15 time units, 5 delay statement will be executed. Okay.
Then at 20-second middle display.
Okay. 20. Okay. This 10 plus 10 has 20 time units. Okay.
Then
Next.
at 30 first display.
Okay. #30 first statement will be executed.
Then
Okay.
Last after join statement also at 30 it will execute.
Okay. 30 plus 40, 70. It will execute, right? Did you understood everyone?
Yes, ma'am.
Okay, here at 30 time units and 30 plus 40 time units, next statement will be executed. Okay, so this is how we can use the fork join, the parallel execution statements. Parallel execution in the sense, whatever least simulation time is there, that least simulation time statements will be executed first, then it will accordingly, the time wise the statements will be executed. Okay, least to highest simulation time. Those are the fork join. Okay, and next question, if you note the difference between blocking assignment, non-blocking assignment, fork join, let me know. Okay, and next question, if A and B are two 3-bit vectors, suppose 3 equal to 1x0 and B equal to A equal to 3-bit 1x0, B also 1x0. So what would be the value of following? A equal to B, A triple equal to B. Equality operator, arithmetic equality operator. So what will be the value here? A equal to B and A triple equal to B. First of all, what is the difference for both? Can you tell anyone?
Triple equal to will check for X and J also.
Okay.
Means case inequality, that is basically.
Okay. So what will be the output here for both values? What will be the value for both conditions?
Second will be true.
Okay.